What does from underscore future underscore import absolute underscore import actually do? I have answered a question regarding absolute imports in Python, which I thought I understood based on reading the Python 2.5 changelog and accompanying pep. However, upon installing Python 2.5 and attempting to craft an example of properly using from underscore future underscore import absolute underscore import, I realize things are not so clear. Straight from the changelog linked above, this statement accurately summarized my understanding of the absolute import change. Let's say you have a package directory like this. This defines a package named pkg containing the pkg.main and pkg.string submodules. Consider the code in the main.py module. What happens if it executes the statement import string? In Python 2.4 and earlier, it will first look in the packages directory to perform a relative import, finds pkg/string.py, imports the contents of that file as the pkg.string module, and that module is bound to the name string in the pkg.main module's namespace. So I created this exact directory structure. _init_.py and string.py are empty. Main.py contains the following code. As expected, running this with Python 2.5 fails with an attribute error. However, further along in the 2.5 changelog, we find this emphasis added. In Python 2.5, you can switch imports behavior to absolute imports using a from _future _import absolute _import directive. This absolute import behavior will become the default in a future version, probably Python 2.7. Once absolute imports are the default, import string will always find the standard libraries version. I thus created pkg/main2.py, identical to main.py but with the additional future import directive. It now looks like this. Running this with Python 2.5, however, fails with an attribute error. This pretty flatly contradicts the statement that import string will always find the stdlib version with absolute imports enabled. What's more, despite the warning that absolute imports are scheduled to become the new default behavior, I hit this same problem using both Python 2.7, with or without the _future _ directive. As well as Python 3.5, with or without, assuming the print statement is changed in both files. I have tested other variations of this. Instead of string.py, I have created an empty module, a directory named string containing only an empty _init_.py, and instead of issuing imports from main.py, I have cd'd to pkg and run imports directly from the REPL. Neither of these variations, nor a combination of them, changed the results above. I cannot reconcile this with what I have read about the _future _ directive and absolute imports. It seems to me that this is easily explicable by the following. This is from the Python 2 docs, but this statement remains unchanged in the same docs for Python 3. sys.path, As initialized upon program startup, the first item of this list, path 0, is the directory containing the script that was used to invoke the Python interpreter. If the script directory is not available, for example if the interpreter is invoked interactively or if the script is read from standard input, path 0 is the empty string, which directs Python to search modules in the current directory first. So what am I missing? Why does the _future_ statement seemingly not do what it says, and what is the resolution of this contradiction between these two sections of documentation, as well as between described and actual behavior?
The changelog is floppily worded. From _future_import absolute_import does not care about whether something is part of the standard library. An import string will not always give you the standard library module with absolute imports on. From _future_import absolute_import means that if you import string, Python will always look for a top-level string module, rather than current _package.string. However, it does not affect the logic Python uses to decide what file is the string module. When you do, pkg/script.py doesn't look like part of a package to Python. Following the normal procedures, the pkg directory is added to the path, and all .py files in the pkg directory look like top-level modules. Import string finds pkg/string.py not because it's doing a relative import, but because pkg/string.py appears to be the top-level module string. The fact that this isn't the standard library string module doesn't come up. To run the file as part of the pkg package, you could do. In this case, the pkg directory will not be added to the path. However, the current directory will be added to the path. You can also add some boilerplate to pkg/script.py to make Python treat it as part of the pkg package even when run as a file. However, this won't affect sys.path. You'll need some additional handling to remove the pkg directory from the path, and if pkg's parent directory isn't on the path, you'll need to stick that on the path too.
The difference between absolute and relative imports come into play only when you import a module from a package and that module imports another submodule from that package. See the difference. In particular, note that Python 2 pkg/main2.py has a different behavior than launching Python 2 and then importing pkg.main2, which is equivalent to using the im switch. If you ever want to run a submodule of a package, always use the im switch, which prevents the interpreter for chaining the sys.path list and correctly handles the semantics of the submodule. Also, I much prefer using explicit relative imports for package submodules since they provide more semantics and better error messages in case of failure.
If you want to see more, please consider subscribing.